Hello, welcome back. In this video, we're going to take 4 different examples to get some practice with the second right-hand rule to determine the direction of force from a magnetic field on a charge. Or, given the direction of force and the direction of motion of the charge, we can figure out the magnetic field's direction. So we'll take different examples to figure out the unknown. All right, the first example I'm going to take is that there is an external magnetic field that's given, and it's given like this. So you know what that means? It's telling you that there's a region of space here where the magnetic field points into the slide. That's what these X's mean. And the question is asking, if I have a positive charge that is flying this way and enters this region where there's a magnetic field, what is the direction of the force that this positive charge is going to encounter? Okay, to do this, you are going to use your second right-hand rule. So the rules were the thumb points in the direction of the motion of the charge. So direction of V of the charge Q. The fingers all point in the direction of magnetic field. And when you orient your right hand, holding it like a formal handshake position, where the thumb is perpendicular to all the fingers and the palm is flat, and then you orient it this way, then the palm facing will give you the direction of force. That force will be from this external magnetic field on this charge Q. So in this case, we're told that the charge is positive, but if the charge was negative, we would then have to flip our answer. We don't have to worry about that this time. So the way you would hold your hand in this situation to make this work is your thumb would have to point this way and all of your fingers will point into the board. So they will look something like this. I can't really draw well, especially when it's representing a 3D situation here. So let me try a different method. I'm just going to use the symbols. So you're looking at your palm, right hand. You held it with the thumb perpendicular to all the fingers and the palm flat. And in order to orient all your fingers going into the page, I'm just going to show the 4 fingers this way. You're seeing kind of them from the back. And I'm going to put X's here to tell you that your fingers are pointing into the page. So don't confuse this with our notation for current, which was a circle with an X or dot around it. In this case, I'm just using this to show you how you have to orient your finger. So this is thumb. And when you do this with your right hand, with your fingers pointing in and thumb pointing to the left, your palm is facing down. So that gives us the direction of force, in this case on this charge, is going to be pointing in the downward direction. And since it's a positive charge, I don't have to flip anything. I'm done. One more example. So now I'm given an external magnetic field that is pointing out of the page. So these symbols are showing you the external magnetic field. And now I have a negative charge that's flying into this region from top to bottom. And once it enters the region of the magnetic field, we want to know the direction of the force. So in this case, I have to again use my right hand, get my thumb perpendicular to all the fingers, flat palm, and now I'm going to face my thumb in the downward direction, and then I'm going to rotate my hand so that the fingers are all pointing out of the slide toward me. So that looks like this. The thumb pointing in the downward direction, and then the 4 fingers are all stacked on top of each other above the thumb, and then they're all pointing out of the screen, facing this way. And when you do that correctly, if you're following me, you see that your palm is on this side and the palm is facing to the left. So the second right-hand rule tells me that the palm is facing to the left. But the 4th condition of the second right-hand rule was if the charge is negative, then I got to flip my answer. So in this case, with the palm facing left, I've got to conclude, because the charge is negative, that the force points towards the right. So the force on this charge is going to be to the right, using the second right-hand rule. All right, let me take a couple more examples and we'll wrap this up. The third one, I'm taking a magnetic field that's pointing left to right. So this is the external magnetic field. And the charge is coming out of the page, out of the screen. So it's coming from the screen toward you. And the question tells you that it experiences a force to the bottom. So the direction of force is that. The direction of the charge's motion is out of the screen. I could show that, I guess, like that. Or I could try like a 3D representation to say this is coming out of the screen. Hopefully that makes sense to you. And it is asking you, the question is asking you, is the charge positive or negative? All right, so now once again, I use my right hand and I point my thumb coming out of the screen. And then I rotate my hand so that my fingers are pointing left to right in the direction of magnetic field. So now when I hold my hand this way, my thumb is pointing out and my fingers are all stacked this way, one behind the other. Okay, so when I do that, you see that the palm is in this position. So the palm faces up. So if this were a charge that was moving out of the screen with the magnetic field pointing from left to right, it would experience a force to the top if it was a positive charge. But the question told us that the force was to the bottom. So we must conclude that in this case, the charge is negative. All right, one final example and we'll wrap this video. So the fourth example tells us that there's a positive charge that's moving in the downward direction and it experiences a force to the right. So Q is positive, that's given, moving top to bottom along the screen. It experiences a force to the right. And the question is asking, what is the direction of magnetic field? All right, so once again, I use my right hand, thumb perpendicular to all the fingers. The thumb has to point down and my palm has to point to the right because the direction of the force is given by the palm. So the palm points to the right. And when I hold it like that, the orientation I get is thumb pointing down and the fingers are stacked on top of the thumb and they're all pointing into the board. I have to be having the fingers pointing into the screen for the palm to be facing to the right, which it has to be because that's where the force is acting. So because my fingers are pointing in, the direction of the magnetic field in this case is into the screen. So if I were to draw the magnetic field on the screen, I would draw it as a bunch of X's. And if this charge was negative, once I got the answer off into the screen, I would flip it and I would have it coming out of the screen. But in this case, the charge is positive, so I didn't have to take that last step. Okay, so in this slice of physics, we took a closer look at how to use the second right-hand rule to determine the direction of force from a magnetic field on a moving charge. We realized that once we are given the directions of any two of these, we've got the direction of motion of the charge, we've got the direction of the external magnetic field, and we got the direction of the force from the external magnetic field on the moving charge. And given any of these two, we can figure out the third. We do that by using the second right-hand rule, and then we have to remember to flip our answer if the charge is negative. Thank you.